Good day. So in this video, we're going to discuss the integration of the trigonometric functions such as cos ax plus b, sin ax plus b, and sec squared ax plus b. But before we get into that, I just want to take this moment to appreciate all those who have subscribed to my channel. And if you are new to this channel, please go ahead and hit that subscribe button and share these videos with colleagues and friends. Now, let's get back to today's business. Right, before we get into the integrals of the trigonometric functions, I just want to jog your memory on the differentiation of the trig function that we did in the previous videos. Now, if you remember very well, we did the derivative of sine ax plus b, and we said the derivative of sine is a cos. So that will be cos in a bracket ax plus a b. But remember, we said we multiply by the coefficient of x. So that will be a cos ax plus b. So that will be the derivative. So this is the general derivative of sine ax plus b. And the derivative of cos, we say the derivative of cos is a negative sign. So in this case, we again multiply by the coefficient of x. In this case, is an a. So that will be negative a sine bracket ax plus a b as well. And also for the derivative of tan, we say the derivative of tan, it's a sec squared. But once again, we multiply with the coefficient of x. In this case, is an a. So then the derivative will be a sec squared bracket ax plus a b. So that is the derivatives of the trigonometric functions. So remember now, the integration is just a reverse of differentiation. So we are now working backwards. So now we are going to find the integral of cos ax plus b, the integral of sine ax plus b, and the integral of sec squared ax plus b. So I will show you in a moment what will the integral of these trigonometric functions be. Now, you remember very well the derivative of a sine was equal to positive cos. But for the integral of sine, the integral of a sine, it's now a negative. And remember, we're multiplying by the coefficient of x. So we just do now the reverse. Now what we are doing, we have to divide by the coefficient of x in integration. So therefore, the integral of sine will be negative 1 over a. Because the integral of a sine, it's a negative cos. So that will be negative 1 over a cos bracket ax plus a b. Then remember, in integration, because these are indefinite integrals, so we say plus a constant c. And also the integral of sec squared. Remember, sec squared is the derivative of tan. So the integral of sec squared going back, that will be a tan. So that will be a tan. So in this case, it will be a tan. Also, we divide that tan by the coefficient of x. So that will be 1 over a tan of bracket ax plus a b. Then remember, plus a constant c for the indefinite integrals. And also now the integral of cos. So remember, the derivative of cos was negative. But in this case, for the integrals, the integral of cos is now a positive sign. And also we divide by the coefficient of x. So in this case, the integral of cos will be 1 over a sine. So that will be positive sign, bracket ax plus a b. Remember, also plus a constant c. So these are the integrals of sine, sec squared, and cos. So you need to memorize these integrals because these are just general integrals. Now let's look at some examples to see how does this apply in some examples. Now, in these examples, the first one, we are asked to find the indefinite integral because there are no limits here. So this is an indefinite integral of cos 3x dx. So if you remember very well, we said that the integral of cos is equal to a sine. So in this case, that will be, so the coefficient of x is a 3. So we would say the answer, the integral of cos 3x dx will be equal to, in this case, we divide by 3. So that will be a 1 divided by 3, then sine 3x plus a constant. Remember, we said the integral of cos is a positive sign. So that will be your answer. Simple as that. So in the next example, we are asked to determine the integral of negative 2 sine a quarter minus 2x dx. So we can just factor out first of all negative 2 because it's just a constant. Then we say integral of sine bracket a quarter minus 2x dx. So then the integral of this will be, so that will be negative 2. Then we multiply by, remember the integral of sine is a negative. So that will be a negative. So negative cos bracket a quarter minus 2x. Then we say plus a constant c. But before we do that, remember, we want the coefficient of, we want to divide by the coefficient of x. In this case, the coefficient of x is negative 2. So we divide this whole thing by negative 2. And if we divide by negative 2, that negative 2 cancels, then the answer will just be negative cos bracket a quarter minus 2x plus a constant c. And that is how you do the integral of negative 2 sine bracket a quarter minus 2x dx. Now let's look at the definite integrals. Now in this example, we are asked to determine the definite integral of sine 2x minus pi dx from the limits of 0 to pi over 2. So one thing that you want to do when you're working with definite integrals in trigonometric functions, you always have to turn your calculator into radian mode. So now, as you remember, the integral of sine, we say that the integral of sine was a negative cos. So in this case, remember also to divide by the coefficient of x. So the integral of sine will be a half. So that will be negative because the integral of sine is a negative cos. So that will be negative half a cos bracket 2x minus pi. Then in this case, we don't need to put the plus constant because these are definite integrals. We've got limits that are given. Then from 0 to pi over 2. Now the next thing that you want to do before you substitute in the limits, you just want to factor out that negative half so that it makes your life easy. Then that will be bracket. Now remember that will be the cos bracket 2, so times pi over 2. So first of all, it's the function of the upper limit minus the function of the lower limit, if you remember. So that will be cos bracket 2 pi over 2 minus a pi. Then bracket minus the function of 0. In this case, that will be cos in a bracket 2 times 0. Then minus a pi as well. Now, then if you simplify that, that will give you negative a half. Then in a bracket, so cos pi. So these two cancels. That will be pi minus pi. So that will be cos pi. So cos pi is 1. Then minus, then cos 2 times 0, that is 0. So cos minus pi, that will be a negative 1. So it's a minus 1 as well. So then the answer will be negative half times a 2, which will give you a 1. That is how you do the definite integral of sine bracket 2x minus pi from the limits of 0 to pi over 2. Now, moving on to the second example. In this example, we are asked to determine the definite integral of sec squared bracket x minus pi from 0 to pi over 4. Now, if you remember very well, we say that the integral of sec squared x is just the tan. And also we divide by the coefficient of x. In this case, the coefficient of x is 1. So the integral now will be, in this case, that will be tan bracket x minus pi. And there is no need to say plus a constant because we are doing definite integrals. Then from 0 to pi over 4. Then we just do now the function of the upper limit, which is the function of pi over 4 minus the function of 0. So then that will be tan in a bracket pi over 4 minus pi bracket minus tan bracket 0 minus pi, because that will be now the function of 0. So if we get that, if we simplify that inside bracket, that will be tan in a bracket, that will be minus 3 over 4 pi bracket minus tan here, that will be tan negative pi, tan negative pi. Now, if you simplify that in your calculator, you will get, so yeah, tan minus 3 pi over 4, that will be a 1. Then minus tan negative pi, that will be a 0. So then your answer is just equal to a 1. And that is how you do the indefinite integral of sec squared x minus pi from 0 to pi over 4. Now let's look at the last example. Now this question is a typical examination question. So in this question, we are asked to show that sine x plus 5 cos x squared is equal to 13 plus 5 sine 2x plus 12 cos 2x. Now to do that, we just expand this bracket. So we just say sine x plus 5 cos x bracket, then multiply by the other bracket of sine x plus 5 cos x. And that is quite easy. It's just your simple expansion of algebraic terms. So in this case, that we get now sine squared x, then this times that plus times a 2. That will be now plus 10 sine x cos x, then plus 25 cos squared x. Now, before you change anything, always look at your final answer, where you want to go. Always look at the final destination. So you want to get sine 2x, and we are happy we can get that sine 2x here, but the final answer should have a cos 2x. So what we have to do, so we need to convert already right away the sine, because the final answer does not have a sine squared. So to convert that sine squared, remember we use the identity of sine squared x plus cos squared x is equal to 1. And we can say now sine squared x is equal to 1 minus cos squared x. So then we substitute that. So for sine squared x, so that will be 1 minus cos squared x. Then in a bracket, then plus 10 sine x cos x, then plus 25 cos squared x. Now, if you want to open, you can open the bracket and simplify that. You can see that will be 1 plus, so 10 sine x cos x, that can be easily converted to, so you can say that will be 5 bracket times 2 sine x cos x. So we're just trying to manipulate that we get the sine 2x here. So that will be 5. Remember 2 sine x cos x. Remember that identity. 2 sine x cos x is equal to sine 2x. So that's what we want to try and get. So 5 times the 2 sine x cos x, then that gives us 5 sine 2x. Then plus, here, remember now it's a negative cos squared, then plus 25, that will be 24 cos squared x. And finally, this can be 1 plus 5 sine 2x, then plus 24 cos squared x. So the last thing that we need to convert, we need to convert this cos squared, because we want to get a cos 2x. So to do that, we use the double angle identity for cos, which states that 2 cos squared x minus 1 is equal to cos 2x. Remember this. Then we make cos squared, because it is the cos squared that we want to convert. Then we make cos squared the subjects. Therefore, we say cos squared x will be equal to, in this case, that will be a half cos 2x, then plus a half. Now, what we want is a 24. So if we multiply this side by 24, we just do exactly the same thing also on the right-hand side. So we can say 24 cos squared x is equal to also 24 here, multiplied by a half cos 2x minus a half. So if you open the bracket, that will be equal to here 12 cos 2x, then minus a 12. Now we have this. So we substitute now this for the 24 cos squared x. Let me just create some space here. Now we can substitute 24 cos squared x with what we got here. So in this case, that will be 1 plus 5 sine 2x, then plus a 12 cos 2x minus a 12. And you can see that this, it's actually not a minus, sorry, that will be a plus here. So that will be plus, so then it's a 13 plus 5 sine 2x, then plus 12 cos to x. And we have shown that sine x plus 5 cos x squared is equal to 13 plus 5 sine 2x plus 12 cos 2x. And that is how you show that part. Now moving on to part 2. Now in part 2, we are asked to calculate the definite integral of sine x plus 5 cos squared. So if the moment when they say hence in a question paper, or exam or whatever, in a class test, the moment when they say hence, then you have to know that you have to use what you have done on the previous part of the question. So in this case, you can see that sine x plus 5 cos x squared is exactly as that. So we do not integrate that. We integrate this because these were like previous examples that we used in the previous questions. Now, so we just replace that with integral of pi over 2, 0. Now we use 13 plus 5 sine 2x plus 12 cos 2x dx. Now, then we know that the integral of 13 is very easy. So in this case, we do not put our constants here as well. So that would be 13x. Then the integral of sine, remember the integral of sine is a negative. So that would be, remember we divide also here. So that would be negative 5 over 2 cos. So that would be negative cos. So cos 2x. And also remember the integral of cos is now a positive sign. Then we divide by 2. So that would be 12 plus 12 divided by 2. Then sine 2x. Then we close. Then we put our limits. So there is no constant because it's a definite integrals. So then that would be from 0 to pi over 2. Now we do the function of pi over 2 minus the function of 0. So that will be 13 bracket pi over 2. Then bracket minus 5 over 2. Then cos 2 bracket pi over 2. Bracket then plus 12 over 2 is actually 6. So that will be 6 sine bracket 2 bracket pi over 2 bracket. Then we simplify that. Then we say minus the function of 0. So in this case, that will be 13 times a 0 bracket minus 5 over 2. Then cos 2 times a 0. Then plus 6 sine bracket 2 times a 0 as well. Now, if you simplify that in your calculator, you just punch that in your calculator, then you'll see that the answer will be 5 plus 13 over 2 pi. Or in decimals, that will be 25.4. Now, this marks the end of our lesson. Now, just to give you a summary. Now, remember what we said at the beginning, that the integral of sine ax plus b is equal to minus 1 over a cos ax plus b. Then also the integral of sec squared is equal to 1 over a tan ax plus b plus a constant c. And also lastly, the integral of cos bracket ax plus b is equal to 1 over a sine ax plus b plus a constant c. I hope to see you again in the next lesson. Bye for now.